Assalamu alaikum. My name is Amna Chaudhary. Now we discuss about its chemical reaction. Chemical reaction involved in the formation of a glass. Forming are the chemical reaction which take place during formation of the glass. First of all, silica react with sodium carbonate and to form sodium silicate. Silica react with sodium carbonate and to form sodium silicate. In the next step, silica react with calcium carbonate and to form calcium silicate. In the third step, sodium silicate and sodium calcium silicate, which is formed by the first two reaction, mix with each other with the silica and to form glass. Contact lenses, composition of a contact lenses as silicon, hydrogel, hydrogen peroxide, soft, flexible plastic, fluorine, oxygen, polymethyl methacrylate hard lenses, hydroethylene methacrylate soft lenses. Soft and hard lenses. Soft lenses, these are made of material called hydroethyl methacrylate, which is plastic hydrogel polymer that has a high water content. The second is hard lenses. They are made of a material called polymethyl methacrylate. Chemistry of a glass. Thousands of different chemical composition can be made into glass. Different formulas affect the mechanical and electrical, chemical, optical, and thermal properties of a glass that are produced. There is no single chemical composition that characterizes all glass. Typical glass contain former, fluxes, and stabilizer. Former. Former is make up the largest percentage of the mixture to be melt. In typical soda lime, silica glass, the former is silica dioxide in the form of sand. Fluxes. Fluxes lower the temperature at which former will melt. Soda, sodium carbonate, and potassium carbonate. Both alkalis are common fluxes. Potash glass is slightly more dense than soda glass. Stabilizer. Stabilizer make the glass strong and water resistant. Calcium carbonate, often called calcinated limestone, is a stabilizer. Without a stabilizer, water and humidity attack and dissolve glass. Glasses begin as mixture of oxide. Their composition can be represented by listening the weight percentage of their components. Compare the percentage of our stabilizer, make the glass strong and water resistant. Calcium carbonate, often called calcinated limestone, is a stabilizer. Without a stabilizer, water and humidity attack and dissolve glass. Glasses begin as mixture of oxides. Their composition can be represented by listing the weight percentage of their components. Compare the percentage for a typical glass, modern soda lime silica glass used to make bottles and windows. Second, library and some baking ware, optical highlights crystal, 96% silica glass, a typical ancient Roman soda lime silica glass. You can see the percentage silica 73%, first typical and modern soda lime glasses. Silica consists of 73.6%, soda 16, lime 5.2, potash 0.6, magnesia 3.6, aluminium 1.6. And the other 4 percentage are as follows: laboratory, optical, silica glass, and typical glass. The main constituent of flat glass is silica sand. This has a high melting temperature in the region of 17 degrees Celsius, and its state at the temperature is like syrup on a very cold day. The basic building block of silica has a tetrahedral pyramid shape with silicon at its center linked symmetrically to 4 oxygen atoms at its corner. It has a chemical formula SiO4 and is negative charge. On cooling, molten silica quickly a random organized network of these tetrahedral are formed, linked at this corner to give an amorphous material called vitreous silica. Now see the reaction. Sodium carbonate react with silica sand at 1500 degrees Celsius and to form sodium silicate, and carbon dioxide is also released. And the other sodium silicate react with silica oxide and to form glass. For practical and economic reason, the high melting point and viscosity of silica is reduced by adding sodium oxide in the form of carbonate, and sodium oxygen atom enter the silica oxygen network. In accordance with their valency state, these atoms is known as network formers. Other major constituents of flat glass, calcium and magnesium, enter the network structure as a network modifier. And the action of these modifiers is to make structure more complex, so that when the components are melted together in the cooling procedure, it is more difficult for the atom to arrange themselves in suitable configuration for crystallization to occur. In the glass making procedure, the cooling rate is arranged such that viscosity increase and mobility of the atom is hindered, thus preventing arrangement and crystallization from occurring. This glass is often referred to as a supercooled liquid in that it has no crystallization or melting point and does not exhibit the phenomena of the latent heat of crystallization or fusion. The most widely used glass are silica glasses formed by silica oxide. Silica consists of 3D network of tetrahedral where every corner oxygen atom is shared with the adjacent tetrahedron. The silica tetrahedral unit is also incorporated into chains and sheets from clay and different ceramics. Pure silica can be made to exist as a glass, and it is also called fused silica. A glass is a material that has hardened and become rigid without crystallizing, making it its amorphous. Silicate glasses are the most widely used glass. All of the most important glasses are based on silica. Two glasses of special interest are soda lime glass used in window and bottles with composition 70% 70 silica, 10 soda lime, 15 sodium oxide, and borosilicate glass. Used in cooking and chemical glassware with composition 80 silica, 15 B2O3, 5 Na2O. The ability of an oxide to form a glass upon cooling and amorphous structure depend on the structure relationship between the oxygen atom and the cation of the oxide compound. In order to achieve a glass structure, the oxide cations will bind with the oxygen atom to form a tetrahedral network. Oxide that form glasses are known as network formers. Common examples are silica, B2O3, gallium oxide, P2O5. Certain other oxides can be added to substitute for silica atoms in the tetrahedral structure. These oxides become part of the network and act as a stabilizer. The oxides are known as intermediates and, in the similar manner to network modifier, lower the melting point and viscosity of the gas, thereby allowing it to be worked at lower temperature. Common example of intermediate are TiO2, zinc oxide, lead oxide, and aluminium oxide. Shukriya.